Welcome to the London Clojure meetup. Tonight, we have the pleasure of having Sathya Vittal with us. Sathya is going to tell us more about Clojure and gRPC. So without wasting too much time, Sathya, you can share your screen.
Okay. Great. Can everybody see my screen?
Yes.
Okay, brilliant. Okay, so hello everybody. Thank you for listening to my blabber while we started the presentation. So welcome to this talk again. So this talk is going to be about overcoming FOMO, right? So everybody knows what FOMO is, at least the young people here should know about it. So FOMO is fear of missing out, right? So this is quite a social thing, but I think it applies to technology as well. When you're picking new technology, or talking to other people about new tech, and so that's what it's going to be about. But the theme would be Clojure and gRPC and how I sort of overcame my FOMO. So through the course of the presentation, there will be a couple of things you're going to have to put up with. One thing would be my screwed up, weird, whatever fake accent. Sorry about that. And the other thing would be like all these scribblings in the presentation. So this guy here with a cap, the cool guy, is basically supposed to be the inner Sathya, who tries to be cooler than the real Sathya, if that makes sense. So he's going to make some sarcastic comments here and there. Stop talking about him now. So let's jump right in, right? Fear of missing out. This is a great time to be working in technology. We all know that, right? Because there's just so many things happening around us, people doing incredibly cool things. However, this happens. This is basically a screenshot from landscape.cncf.io. So it's basically the container native foundation and all the different technologies that are incubating or has made it through to the CNCF list. And I've basically zoomed this thing a little bit. There are way too many boxes in there. So when you see things like this, when you go to websites like this, so how do you feel? How many of these boxes have I even been introduced to? How many of these things do I even know about, right? And you worry, right? You obviously worry. So that is FOMO. My friend actually pointed out that, like, what are you talking about? FOMO is basically a social thing, right? It's true, it is quite a social thing, but I think it applies to when you're dealing with technology, when you're trying to learn a new tech, or when you're trying to build anything as well. So I was researching on this when I found an article on psychologytoday.com, which was really nice. They say that the things to look out for, or when you think these things, when you think, oh, I might make a bad choice. What if I make a bad choice, right? This basically undermines your confidence, and it feeds all these if only or what if questions. It may or may not be good for you. These things are good when you have a small amount of them, but if you have a lot of what if questions, you're actually not building anything. You're only continuously going in a loop, right? Happened to me with Prometheus, selecting Prometheus, or not selecting it, I would say. And the next thing was, oh, they're having fun without me. This happens a lot, right? A lot of people, I'm pretty sure, feel this way, that your colleagues or ex-colleagues who work in another company or working on something really cool, they're using a new tech, and you're stuck working on an application like a Java Spring application talking to Oracle. Not that there's anything wrong with it, but it's basically gives you the feeling of envy, right? Because you couldn't get there, you couldn't muster the courage to go do something cool. So that's another symptom you feel. And the third one is clearly like, oh my God, I'm a loser. You feel this when you have a lot of insecurity. You feel, oh is my CV going to be good enough when I leave this company? Right? Or when a new challenge presents itself in the current company, am I going to be up for it, right? When they try to implement a change management program, are they going to consider me as a developer for this? So you can see how something that applies to all this social media or social anxiety actually applies to tech people as well. We go through a lot of them. So I went through this. I identified that this is basically FOMO because there was a point when I was thinking, uh, I was trying to pick stuff to build the the first application, which is a chatbot framework. So there were so many things I was considering. What's the monitoring technology? What should I use for log aggregation? Do I use Kubernetes or ECS? So many things. And I was actually, there was a time when there were 2 weeks when I did nothing. And I was just thinking about it. I felt like I was working 15 hours a day, but the output was zero. And when I analyzed it, I realized that this was basically just FOMO and all these things that were making me, less productive and more anxious. So the causes for FOMO is basically the lack of three things. The first thing is competency. And when I say competency, it doesn't mean, oh, you're not competent enough. It means you don't know that, you don't understand that technology, you're not aware of it. The second one is about making meaningful choices, right? How many of us have worked in companies where people just pick a technology because it's cool or it's the first thing that they know of, right? Rather than really thinking about what actually needs to be done. And the third thing is correctedness to others, which is basically saying you are comparing yourself with what other people are doing without the notion of context. So in terms of solutions, that website suggests a few things. So one is increase your understanding, understand what's being said or done, right? So the best way to do this is to analyze benefits and packages. I've realized that recently we started talking a lot about pros and cons, advantages and disadvantages. And in life, it doesn't work that way, right? Like depending on the context, depending on time, an advantage can become a disadvantage. So I think those are not the right ways to use the right words to use. You should use words like benefits and baggages. So what are the things that I get and what are the things that I have to put up with? So the next thing is you have to understand that you cannot do everything. It's an obvious thing. And look out for FOMO being used against you. Very important. Look at this stuff, right? I remember going to a conference once. I think it was the Red Hat OpenShift conference. It was so cool. A lot of interesting things being presented. But if you look at the number of advertising and marketing things that are going on around there, it's actually mind boggling. So like watch out for it. So you could get caught up in all the noise and like not be productive. This can affect your productivity. So watch out for it. And finally, you need to have a plan. So when you don't have a plan, you feel anxious and you're worried about everything. When you do have a plan, you stick to it, you can live a happy life, right? So enough of the psychology lesson. Let's move on to the topic a little bit. So this is to just set a context, right? So I didn't want to actually have like a detailed architecture diagram of what we're building. So don't look at this diagram and judge me, right? I'm not responsible for it. So as I was saying during the pre-talk thing, we are now building an application to allow customers to quickly replenish their frequently purchased products. So effectively, things like your coffee tin will become a smart device where you just tap your phone and then reorder it. It would be so cool, isn't it? There could be so many things you could do that way. I think we found really a good sweet spot there. And so once we decided this, we realized we need to build this and get to market really quickly. So I, as the CTO of the company, had the responsibility to design this, right, and build this. So then all the FOMO starts coming back again. So you are faced with so many questions. You're like, okay, did I make the right choice when I built the previous application? Is my current technology right? Is it going to scale? Is it going to be adaptable for the future? So there are so many questions, right? But thankfully, I had answered most of these questions already this year. Once I've gone through this motion where I selected the right database for the application, I have to say, the suitable database. Again, see, right and wrong, don't use those words. So the database suitable for my platform. We picked the platform suitable for our platform. We made a conscious choice not to use Kubernetes because in terms of the sort of skill set and the time we have, the cost, we picked ECS because of that. So Terraform or CDK, you get the idea, right? There's so many things you have to talk about. But the application itself is very simple. It's basically an API which has a public part and a private part. The app on the mobile phone talks to the API to get data. and the API has connections to various e-commerce platforms and payment platforms, right? It's basically like an e-commerce store, but a lightweight version of it running on your phone. Very, very, very simple. So of all these questions, one question still stuck in my head, and I didn't manage to answer this early this year because we were in a rush. I spent a lot of time answering other questions. I put it on the back burner. So I ended up using REST. So we have typical Clojure API-based Clojure applications, which are all REST APIs which talk to each other. So I thought maybe I should spend some time answering this question, right? So go to market, when you say you have to go to market fast, you don't have to rush to market, leaving behind all the important questions. So I thought I'll spend some time to answer this question. So GraphQL is an interesting one. Maybe I'll cover that in another talk, I think. But let's just focus on REST versus gRPC. So as I said, in terms of the solutions for your Fomo, the first thing is to try and understand what you are worried about, or what you're afraid of, or what you're afraid of missing out on. So I did some research. So I'm going to walk you through some of my findings here. So there you go. So gRPC, gRPC.io website has a tagline that says, this is a high performance, open source, universal RPC framework. Nobody can explain this any better, I bet. So I like to do this thing where I look at each item, each word in a tagline, and try to see what it is. So that gives you like a comprehensive understanding of it. So high performance, right? So how do they get high performance? It's high performance because it uses HTTP 2, which is supposed to be incredibly faster than HTTP 1. And then it also uses Protobox for serialization. I've used Protobox before. I love Protobox, and I know how fast and efficient they are. So good, the high performance thing, check. It's open source, which is brilliant. Given that it's backed by a company like Google, it has a fast moving, thriving ecosystem. There are a lot of tools to help you develop and monitor and run gRPC services in production. Then universal. So what this means is it is not something that's tied to a particular specific language. It's not something that only works in Go or Kotlin or something like that. It's one of their objectives to keep this technology universal. So which is to be able to idiomatically build applications in the language and platforms that you love to use, right? And then the framework part is basically very interesting as well. Like as Clojure devs, we don't like the word framework a lot, do we? But here framework actually means structure. So what's the sort of structure it gives you? So it sort of brings this idea of a service definition back into building services. So we used to have web services stuff. Do you guys remember that? Write a WSDL first and then generate code from it. Then all the bad habits came about where people generated WSDL from code. And then I think there were like at least hundreds of WS star standards, which basically meant that people didn't care about it anymore and dropped it and moved to REST. But I think we missed a cool part. Because we tried to make things easy for development, we lost this whole notion of having an effective interface definition language, right? So we do have Open API and Swagger and things like that, but let's face it, it feels quite loose and not that effective. So gRPC brings that back. You can basically write a service definition using Protobuf itself. It's pretty cool. And also using Protobuf for serialization makes it a little bit faster, although you can now use JSON and other serialization technologies if you want. And most importantly, it gives you a development model. So it says that, okay, so you can now build 4 types of APIs. So you can have a unary RPC, which is basically like calling a function, passing in a request and getting a response back, right? So that's unary RPC. Then you can have server-side streaming. This is where the client sends the server one request and can get multiple requests streamed back to it. So imagine things like when you're getting updates for an application. So someone's looking at a dashboard and you want to get updates for it, you could do that this way. Then you have client-side streaming, which is when the client sends multiple requests to the server in a streaming mode, one after the other, and then the server sends back one response. This is really useful when the client has to transfer huge files or big images to the server for processing, right? And then you have two-way streaming, right? Obviously, which is actually super cool. So if you want to write, let's say, a ping pong application, you can do it. No, there are really good use cases for it as well. So that's the framework part. It's really nice. And then the whole RPC thing, right, makes you wonder, gee, RPC again? But I think there are a lot of people debating the whole REST versus RPC thing. I think that there's not going to be a winner here. There are going to be people who like the REST way of doing stuff, and there are going to be people who like the gRPC way of doing stuff. It's again going to come to typed languages versus untyped languages, Emacs versus Spacemacs, right? Google versus Apple. It's not going to that. There's just way too much material on that. I won't do that. But personally, I like the whole function call like semantics to calling remote APIs. I like not having to worry about whether my API or my URL path, fits into the REST pattern. Am I doing the right thing here? Is it obvious? Sort of avoids all that, which is good. And also, gRPC is an improvement over REST, but it is actually not very far from it. It still uses the same HTTP-based principles to allow you to build RPC services, so which is pretty cool. So, and if you look at the little like doodle the diagram at the top left there, this is how applications talk to each other. There is an interface definition language, and there are a bunch of Protobox definitions for every request and response that you have, which will be shared among the services that talk to each other, and these services talk to each other using Protobox. Although, as I said, it's possible to use JSON and other serialization techniques now. Okay, so now, how many of you have read an article in Wikipedia, right? And then there's a reference to another thing that you don't know, you click on it. And then there's a reference to another thing you don't know, you click on it. And then after 5 minutes, you have no idea what you started researching, right? So it can be like that sometimes when you're looking at stuff. So when I started looking at gRPC, the thing that kept sticking out was the whole use of HTTP2. So I had to go understand what the benefits of HTTP2 really are and like how it's trying to achieve this stuff as well. So here's a quick slide on that. So HTTP2 is based on Google's Speedy protocol, which is now deprecated in favor of HTTP2. All the goodness is now in HTTP2. And the main objectives are to reduce the latency of loading web pages and to improve security, right? Two objectives. So us API developers always think, when we think about HTTP, we are thinking API calls, right? Thinking API calls, how do services talk to each other? How do I make that work? But sometimes we overlook the complexity in implementing stuff on the browser, making things load faster on the browser. So that's what all these improvements are about. What we get on the API side of things is just like a nice little side effect, right? So there are three things I want to highlight as the features of HTTP2 that really intrigue me. The first thing is how the whole resource loading is done. So the first diagram there is basically HTTP 1.1, where you have a single connection, and when the client requests a resource from the server, you have a single connection. Well, not single, we'll come to that in a bit. In a single connection, a request is sent to the server, and the server will fulfill it, and the client has to wait until the server fulfills that request to then send another one, right? So that's how the pipelining works. So because this is sequential, people try to work around it by actually adding support for more connections. So you could have more connections to a particular origin, so you can try to load resources in parallel. But as you can imagine, this doesn't solve the problem fully. You still have what's called as head of line blocking, when the browser actually requests a huge resource like a big image or a big JavaScript file, and the rest of the resources are pending. So what you see is like a web page that's stuck, rendering halfway, right? It's not a great thing. So HTTP2 solves this by basically encoding the request and the response into smaller packets of information, and it only uses one connection. But it has this logical notion of a stream, and it basically sends these packets to the stream. Because the packets are already split and multiplexed in these streams, the server then collects all these packets, it then basically recreates the message and then attends to it. And the same works the other way around as well. So this makes it really, really fast, and your resources actually load much quicker, or you get the perception of your resources loading much quicker than in HTTP 1. Plus, because it's a binary framing, because of the binary framing technique, things are actually really fast as well. Okay. The second thing is compression. So HTTP 2 tries to reduce the latency again by compressing the headers as well. So using HPAT, and they also have this notion of having fixed header names with integer codes for them, making it really, really easy to convert to binary and then send it over the stream. So the request response sizes in HTTP 2 are far less than the request response sizes in HTTP 1, which gives you a latency improvement as well. But the coolest thing, I think, in my opinion, is the server push stuff. This is cool, right? Imagine, look at this little sequence diagram like thing I've gotten here. So between the client and the server. Forget all the cross lines that are coming from the server. So if you're only looking at the client requesting resource A, which is actually, let's assume, a really big image or a JavaScript file, until the server finishes loading that, there's nothing that happens between the client and the server. The connection is basically idle, doing nothing. But now the server can kick off the whole IO process or whatever it takes to satisfy that request in the background. But it can also say, look, I have more time to work on this stuff. And I know that you're going to request these resources, right? So this works based on, in HTTP 2, it works based on some hints coming from the client. So to the elements, to the links that you have in your web page, you can add tags that say, oh, this is something I need first, right? Or this is something I definitely need to load. The server can look at those things and then it can say, okay, you know what? I'm going to push B to you. And then it's going to start pushing B. And then it says, I'm going to push C to you. It's called a promise, a push promise. And then it's going to start pushing C. As you can see, the idle time is really effectively used. And where in HTTP 1.1, you would have just gotten A at that point, now the client actually has gotten B and C as well. It's cool, isn't it? So this is how cool HTTP 2 is. So we can be sure that it's going to be fast. Right. So I know this is cheesy, but bear with me, right? This is, to use Steve Jobs' building analogy. I don't know how many of you are crazy enough to see all his talks, but in one of his talks, he tries to explain why OpenStep is so cool compared to all the other frameworks, and he uses this analogy. So I'm going to try to do this here as well. So if you use HTTP 1.1 and REST, you're basically building an application on the second floor, which means you have a two-storied app or a two-storied service. You get those benefits. But once you introduce HTTP 2 in there, which brings all these performance improvement features, and then you build a REST app on top of that, you are actually building a 7-storied app or a 7-storied service, right? But if you add gRPC on top of it, which gives you a nice little structure to building your APIs, it gives you the ability to serialize using Protobox, it gives you bidirectional streaming APIs and like idiomatic support in multiple languages, you are building a 10-story app. Who doesn't want a 10-story building as opposed to a 2-story building, right? It's so easy to understand this way. So it's a no-brainer choice. Right, so let's talk a little bit about Clojure support. So as I was saying in the pre-talk, I've been flirting with the idea of using gRPC for a while, but the whole notion of generating Java classes and then writing transformation functions to transform cool Clojure maps into Java classes before I send them out wasn't for me. So I kept pushing it back and saying, maybe I'll write a library for this. You know, we know how that goes, yeah. But during this period, a few people have actually built a cool library called Clojure. So it actually has a few components to it. It comes with a Clojure plugin to the Proto compiler to generate idiomatic Clojure code rather than Java classes. And it comes with batteries included support for pedestal. You can basically extend it to support ring as well. And it also has uses co-racing for client and server streaming. So the APIs, they look really cool. I'll show you that in a minute. and it's being actively developed. I asked some question on Slack, they responded immediately, I reported a bug, and even before I could go and raise a GitHub issue, it was fixed and there was a new release. So it's really pretty cool. So they're really set to delivering a cool first class experience for gRPC. So after this talk, if more people use it, I'm pretty sure it can contribute more patches, and this will become a de facto thing for all us Clojure devs. It also has this thing called in-process gRPC web proxy. I'll talk about this after the demo, the whole gRPC web thing. I'll tell you why it's important and how an in-process gRPC web proxy actually might simplify things as well. So there you go. So I'm going to do some, I'm going to demo something to you, and let's face it, I'm not Boris Stokes, yeah. So I can't write a mini Camrun live while I'm on a Zoom call, but I already have prepared a repository and some instructions on how to run this. So I'm going to be copy pasting some code here and there and walking you through it. Nothing can go wrong here, right? So let's dive into it. I'm going to stop my sharing and start sharing my Emacs. Okay. Can you see my screen, my Emacs screen?
No, we see a white page.
A white page? Oh, that's Zoom gone wrong, I reckon. Sorry about that. Better?
Yeah, now we see. Can you increase the font a little bit?
Sure. Seconds. It's better?
Yeah, that's okay. Thank you.
Okay, so cool. So for some weird reason, Zoom is only letting me share one application at a time here. But after the presentation, I'll basically send you a link to my repo in GitHub as well, which basically is like a repository with a simple web application plus a bunch of instructions in the README to help build a gRPC service as well. So I'm going to walk you through that now anyway. So I've got the REPL running as well. It's a typical Clojure project. And I have a main here. See that the font has gone wrong. There. So let's start this. So this is basically a pedestal application serving a simple endpoint. And if I hit, it's going to be annoying to not be able to show the browser while I'm doing this. Sorry, Bruno, can you see both my browser and Emacs now, or is it still just Emacs?
No, just Emacs.
Okay. Okay. It's just too cool to not share it with you guys. So this is what this web app does at the moment, right? It basically serves one endpoint with whatever data. We are going to add a gRPC service to it. Okay. All right. So there are a couple of prereqs you need to do. So you need to install the Proto-C compiler, the Google Proto-C compiler, and also the Protojure plugin for Proto-C as well. I'll try I never use the Emacs shell, Altex shell, I think. It's a little bit embarrassing. There you go. Okay, cool, not bad. All right, so I have a makefile here. So the makefile basically calls the proto compiler with the Clojure plugin, and it says generate all these protos. So to develop a new gRPC project, you need to write a protocol buffer definition, like a service definition protocol buffers. So let's test that the whole plugin installation basically works. So in the repository, when you start, I have a sample protobuf, which basically defines a new message called person, which has one attribute called name, right? It's got a package definition, and this is this protobuf syntax. So I'm just going to say make all here. You can see that. So there's a couple of files generated. There's one Clojure file generated by this one, which basically has a bunch of def records and functions that help you serialize to and from Protobuf, right? Let's give this a go in the REPL. To sample. Oh. Nothing can go wrong, right? Sorry, I'm just gonna, I promise I'll warm up. It's translator. Come on. I told you I'm horrible at this. So to create a new person record, you just do sample new person, and you can basically pass in an idiomatic Clojure map, right? Like this. So there you go. So this is basically created a new def record. And to serialize it to Protobuf, you just do, so I'm gonna try and copy paste that thing a little bit. Yeah, that's it. Say proto to protobuf, that. And you see that it's being serialized into a byte array, right? So if you want to serialize it back, just say sample protobuf to person, and you can see that it's basically deserialized it into a Clojure map, right? It's basically a def record of type person. So this is really cool what they've done. So this means that you don't need this layer to basically translate your Clojure map into a Java object and back again. So this is the basic building block for Protojour, which I think is pretty cool. So let me wrap this in a common block. Need some discipline. Okay, done. So this is right? Now let's dive in and write a service. So today I'm going to develop a little translation service using Amazon's translation service. So I have a little core namespace here. So I'm using Amazonica for the Amazon API. So there's a function called translate, which basically takes a given text and a target language and translates it, right? It calls the Amazon's translate API and returns the translation back. So let's just see how this works. Here there is hello world, and I'm going to translate it into my favorite language, which is Tamil, right? Yeah, I can see that. It's done a pretty decent job at it, right? So hello world is Vanakkam Ulagam, so it's good. So this core service works. Now we're going to use this as a basis to build gRPC services. So the first thing you have to do is to write a Protobox service definition, an IDL. So I'm going to go back to resources, protos, and then create a file called translation.proto. I'm going to do this. So you can see that here I've got syntax as Proto 3. There are Proto 2 and Proto 3 are both supported, but we'll use Proto 3 for the purposes of the demo. I've given it a package name, and then I have a service called translation, which has one RPC function in there. The function is, the RPC call is translate, and you can give it a translation request, and the function, the RPC will return you a translation response, right? And the request is basically a text and a target language. For the sake of simplicity, this service will always translate from English to the target language. And in the response, you'll then have the language of the result, what the source text was, and the translation as well, right? Very simple. So in order to do the thing, again, we need to generate the proto files. So I'm gonna do gmake make all, 3 alls, right? And I'll do a refresh. Now, if we go inspect the results, so you can see that there's a translation namespace, right? Just like the sample that was generated, which basically has the def records for your request and the response and the functions needed to serialize to and from them. And you also have another folder here where you have the client and the server stubs generated for you. Yeah, so and in the server stub, you can see that there's basically a protocol generated for you called service, which is because we call that thing service, and then which is with one function in there called translate, which takes params. This will basically be the request that you get from Pedestal. And then there's a bunch of metadata here as well. So if you look into this metadata, this is information about the RPC itself, right? It's out on the table formatting. It wasn't me, it was the generator. So you can see that it defines the what do you call the transformation functions for the input and the output. We saw that with the sample, didn't we? So it does that. It also says that this is not a server streaming API. This is not a client streaming API. And it also says the name of the service and the method and certain other things which we don't have to bother about right now. And the same thing for client as well. It would have generated a client function for you, which called translate, which is basically a unary RPC call. So let's go ahead and build the server now. So to do that, I'm gonna do this here. So I'm basically the server namespace, the translation server namespace, and these specific
response namespace. Okay. Can you all still hear me okay? Is it fine?
There is a slightly echoing sound, but it's okay.
Okay, my AirPods just ran out of juice, so sorry for that. So I've imported that, and then our core namespace as well to do the actual translation. That's here as well. Good stuff. And now we'll implement the service, right? We saw that there's a protocol that was created for us, the translation server service protocol. So I've just created an implementation for it now. I have basically implemented the translate function. So all it does is it checks if and the most important thing to note is that if you've already used pedestal, for example, when you use JSON, you get the request as JSON params, and if you use EDN, you get it as EDN params, right? So the gRPC request comes through as gRPC params, the Protobox stuff, the interceptors basically pass it that way. So your request will already be deserialized into the Clojure map like that. Yeah. So I'm just putting gRPC params from there, and I know that it's going to have a text and target language. And I'm calling the supported languages. I'm looking up the supported languages set to see if the target language is supported. If yes, I'm returning the response of calling the translate function. Otherwise, I'm returning an error. Yeah. Very simple stuff. So that's my implementation. So the next thing you need to do is to make sure that the roots are added to your roots map, the pedestal roots map. So here. So Protobox gives you a namespace with functions to auto-generate these roots as well. Because the roots is in there. Wrong number of arcs constant. Oh, sorry guys. Okay, so if you inspect this, for example, so you can see that a new root has been added for our gRPC call. So this is the namespace, and this is the function. It's basically going to be a post. This is all gRPC stuff, and you can see the bunch of pedestal interceptors that are at play here as well. Okay. So cool. Now we've done this. Let's give this a go and test it. So I'm going to show you a browser, show you my browser. You can see my browser here, right?
Yep.
So I'm basically starting up. The reason you can't see what I'm doing is because Zoom is not allowing me to share my entire desktop. I'm having to do some things on the terminal while I'm showing you this stuff. I'm sorry for the wait. I'm starting up a little UI tool called gRPC UI to then show you this call before we write our client in Clojure. There you go. So now you can see the gRPC UI, right? So basically allows you to pick a service and what method you want to call, what RPC you want to call, and you can send it a text here. Select the language here, so German, for example. So you can see that the response basically has a bunch of headers and the response data as well. Like, pretty cool, right? So we literally wrote a gRPC service. I mean, if you sort of subtract all the, fumbling that I did, we probably wrote a new gRPC service in about 10 minutes, which is sort of pretty cool. So let's move on to doing the next stuff. Let's maybe implement a server streaming one, or maybe let's write a client in Clojure first. So that would be a good thing to do. Okay, good stuff. So you saw that the client was auto-generated for us as well, right? So when we did gmake all, it generated the client for us as well. So we'll require a few namespaces here again. So I'm basically importing this HTTP2 namespace, so we can use the Jetty HTTP2 client to connect to our service. And I'm requiring the translation client namespace, which was auto-generated for us, and also the namespace that contains the functions to serialize and deserialize the translation messages. Okay. So now, to create a new client, a gRPC client, you just have to do this. So gRPC HTTP2 connect, and then you give it a URL, a URI, and you can also set an idle timeout. So if you set it to -1, this connection will never time out. Well, there is a bug here. I've seen it, and I've raised it with the Protobox guys, which I'm pretty sure is being fixed fast. So when you stop the server and restart it, the client sort of gets into a weird state and it doesn't work. So yeah, until that bug's fixed, I'll be recreating the client again and again. But this is how you create a client, very simple. And then to call your RPC, it's just one function call, like you do when you're calling your local function. So I'm just calling the client namespace /translate, passing the client, and I just give it an idiomatic closure like this. It's crossed. Oh, you can see the response here, right? And I got the response back as well. This is pretty cool. So writing a client is super easy with this as well. This is the thing that I love about Clojure, and the same thing that I love about Jackdaw, the Kafka library from the funding set guys, is that it feels really idiomatic when you're writing this stuff. You don't have any Java classes to meddle with, and to create a new client, you're not writing 10 functions, 10 lines of code. It's really cool. It feels really, really easy to do. So let's move on and do something cool. Let's implement a server streaming stuff, right? So to create a server streaming API, so again, we need to extend our IDL, right? So we're going to change here. So I'm going to add a new RPC thing here. I'm going to say translations. So what if we had a streaming API, which when given a text, will return you translations in all the supported languages, right? That will be cool. So give me translations for, because we don't have a target language here, so we need a new request type. So put a new request type here called streaming translations request. So a message as well. Yeah, so it basically has just the text attribute in the request, and then it will return a stream response. So that's it, as simple as that. So it returns stream translation response. So I'm going to run gmake all again. Yeah, I know I keep saying gmake all, but it's just a matter of habit. So let's go into the service namespace and actually build this streaming service, right? So we saw in the presentation that Protobox actually uses core async to do streaming stuff, right? So let's require the async namespace. And let's add a new function. Oh, let's look into the service protocol here. So this is the service protocol, right? So we need to refresh that. Refresh the repo. So you can see. So you can see that there's a new function added to the protocol, right? Translations. which is cool. So let's go implement that. Okay, so as you can see, it looks very simple, right? To do a server streaming API, it's really simple. So when you have a server streaming API, Protobox creates a channel, a core async channel, and passes it in the request map for you. So it's available in the gRPC out key. So I've just gotten the response channel, the async channel, and we basically just need to put the responses to this channel, and it will be sent through as a server streaming thing. It's super cool. So I have a thread here, and within this thread, I'm basically, I know that there are better ways to do this. You can have parallelism and stuff, but just for the sake of the demo, I wanted to send the responses one by one so we can see this thing actually happening. So I'm just doing an async block put to the channel, the result of translating the text for every language in the supported languages set. Right? It makes sense. So that's it. So I'm going to refresh. So now, because our stuff's got loaded, you should be able to see the stuff in our UI. You'll have to restart the UI as well. All right, so now you can see that we have two functions here. There's a translate and translations. It's called the translations RPC. So there you go. So the response was a streaming response, right? So you can see each response that was sent to us from the server. So you can see that they all have a language, a source text, and the actual translation for it as well. This is pretty cool. Actually, let's inspect the network tab and see how this response. All right. We'll have to do this again to see. All right, so if we now look at preview, look at the response object pre, you can see that there are headers and the request. There was only one request sent, and if you look at the responses, so as you can see, this is not a response which has an array. This is responses you got from the server. You can see each individual message coming through from the server. It's cool, right? It's pretty good. So right, so now we've done a unary RPC call, we've done server streaming, and let's do client streaming as well. Actually, maybe let's do a client first. Let's build a Clojure client as well. So require the async namespace. I'm going to create an output channel. So this is the channel in which we will receive the responses. Okay, and what we call the client. So you create the client like you did last time, yeah, and then the code to call the client is for streaming is basically the same as you did when you made the unary call. You're just saying call the translations function, passing the client and your request, but you also you also pass in the output channel. So this is the core async channel where all the responses will come to. And to basically inspect the output, I'll basically write a little go loop which will print the responses, right? So I just started the go loop. So now as soon as you put stuff in the output channel, you should be able to see the responses now. Oh, oops. Exception. I told you this is the bug that I was talking to you about. I raised this with the Protobox guys. But it'll get fixed really soon. Yeah. As you can see, The server is basically pushing these responses to the channel, and our Go loop basically printed everything on the in the console, and you can see that it also said the server also closed the output channel, so our Go loop exited as well. So this is pretty cool. So I know that I really slowed down during the demo, Bruno. How are we doing for time? Do we have a time limit for this?
I think you should start wrapping up.
Okay, cool, awesome. So bidirectional streaming is very similar to the server streaming stuff. So instead of just having one channel where the server pushes responses, you basically can also have an input channel, and as you push stuff into the input channel, you can start receiving response in the output channel. It's very straightforward. I'm just going to quickly show you the code for it for the client. You can see this is what you do. So you can have two channels here, and then when you make the call, you say translate stream, and then you pass in the input channel and the output channel, and then you just start sending requests through the input channel. The responses get streamed through to the output channel. So that's it. Let me go back to the presentation. So I did some really lame, hacky load tests. So my intention was not to come up with a proof during the session to then say, look, this is way better than the rest of the stuff. My intention was to basically set up a repo and keep it ready, so when we develop our services here, we can actually do some proper load tests and then see how it performs as opposed to our current services. But it was nice to see that the gRPC test. So I did 3 tests with HTTP 1 and REST, HTTP 1.1 and REST, HTTP 2 and REST, and also HTTP 2 with gRPC. And the service was basically something that would return a 500 kilobyte response by looking up a massive atom database, right? It's basically a Clojure atom. I found that during the tests that these 3 things weren't off by much. So there wasn't like a startling difference. That's a good start, right? If I found something weird, then it would be something to worry about. They weren't off by much, but we did get better throughput with gRPC. So we did respond to more requests with gRPC. Watch out for updates from me on Twitter or even meetup.com. I'm planning to open source the repo and do some more tests in the coming days. All right, so this is the most important part, I think. So we've looked at all the benefits, the shiny stuff, Protobox library, it's all great, right? But what about the baggage? It's most important. So what does this actually bring that you're going to have to live with? You're going to probably suffer with. So from my perspective, the first thing I see is the compatibility with my current infrastructure. So my infrastructure at the moment is quite like a layered cake sort of thing, where I have a public load balancer where all the which is exposed to the internet. Then I have a bunch of services running in ECS, which are all the public services. To talk to all the private services, they do that through the private load balancer, right? So you get this is like typical stuff that you find everywhere. The problem is these are layer 7 load balancers. So they do support HTTP 2, but the HTTP 2 terminates at the load balancer. And then the load balancer uses HTTP 1 to communicate with your services running in your ECS cluster. This is great, but gRPC is HTTP 2, right? So the backward compatibility is provided by using a layer in between. So this is where you can use gRPC web. It was originally created because the browsers, although they support HTTP 2 and they use that to load their own resources to load web pages, they don't expose these APIs properly to the app functions. So the gRPC team came up with this thing called gRPC web, which translates your requests to gRPC service and back. So this is basically like an envoy plugin. So you know the envoy stuff written by Lyft. So you have to add a gRPC web sidecar to each service in order for your the incoming HTTP 1 request to be fulfilled. So in terms of the negatives, as you can see, there's a lot of hard work for me. I have to change a few stuff, make things work. but I may not get all the benefit of using HTTP2 end-to-end, right? Like, what's the point? But the positive is that gRPC works this way, it's compatible and it will work this way, and it will be forward compatible with my new infrastructure when I decide to change it and go, HTTP2 end-to-end. The solution is actually to use app mesh. So if you use AWS app mesh, this is what I'm going to do. Of course, there are several ways to achieve the desired result. This is my way of doing it. So I'm going to use AWS app mesh to then have all the gRPC services, the internal ones, join the app mesh and talk to each other. So that way I'll get HTTP2 within the internal services. And you can now have a virtual gateway as well, with using which you can put an NLB before your app mesh and then expose your API to the public. So as you can see, negatives are it requires big change to the infrastructure. Positives are, hey, I'll get a new modern, fully HTTP2 architecture, right? Fingers crossed. So the other point is that it's still RPC. You still need to generate, client and server stubs, and you rely on the fact that the clients and the servers, they play well together. They all handle things the way they must be. So you still have the niggle. You can argue clearly that all the HTTP client and server APIs, they have a level of maturity that probably you won't have with this. I did some digging, and I have this habit of going and looking at the issues in GitHub for different libraries when I'm looking at them. So when I looked at the Swift library, and when I looked at some of the other libraries, I found issues in there which look very essential for proper operation, but are still there. So that's something that needs to be sorted. So Protobuf is fantastic, but it stops there. So in Protobuf 3, the required and optional qualifiers for the fields have been removed because of how much hassle they cause people when they try and change them, when you try and evolve them. So which means that now within your application, you have to use either schema or Clojure spec to basically implement your request and response validation and coercion. So that's something to be aware of. And certain aspects of Protobuf are library specific. So enums, for example, is the crazy one. So if you have a situation where you have to add a new thing to the enum, a new item or new attribute to the enum, the client library, which is deserializing the message, can choose to handle it in different ways. It can throw an error, or it can set it to the default value. And you can read Google's documentation. They say that, oh, this is client specific thing. So make sure that you're doing the right thing when you're making changes. So these are things to be wary of. These are things that you don't find. Well, we have different problems in there, but these are new things that you should watch out for. So Clojure is an amazing library, and it's being developed really fast. But there are still some rough edges around even simple things like the client keeping a connection alive. So hopefully it will be sorted very soon. And the framework itself, one of the issues I found is that error handling is still a little bit open. So I love the fact that there's a structure for a lot of things, which is good. But in terms of error handling, it's left to implementers. Google has a library full of Protobox messages where they say, oh, this is a better way to send request validation messages. This is a better way to send this error message, but they don't actually give you any structure around it. It's up to you. It can be a good and bad thing. It allows you to be creative and simple. At the same time, it's something that people can abuse for a period of time. So, right? So this is my plan. It's very simple. I love the idea of my services implementing a service interface. And I can already see it. As I told you, your application has to interface with multiple backends. Right? So it has to be integrated with different platforms, external platforms, and we have a plan to hire freelancers to build more integrations, right? And these freelancers may not be able to build stuff in Clojure. We may have to make a business decision to quickly build something in a language that the developer is familiar in. God forbid, it could even be JavaScript for Christ's sake. But having a good service definition language and and being able to say, okay, if you're building a new store integration, this is the gRPC service you should implement, would be perfect. So that gives all that makes me define all the canonical models up front. That helps me use all the services properly and keep my system polyglot and move in a really truly agile fashion. Moving to app mesh, let's face it, it's going to be inevitable. At some point, everybody's architecture is going to look like that. It's the next wave of things to come. It's still beneficial, so I think the decision has been made, right? So I've overcome my FOMO by actually not missing out on it. So I'm still going to launch the service as a monolith, right? I think Bruno knows it when I say that I always set out to build a Ferrari or buy a Ferrari, but there's only so much you can afford. So probably settle for a Prius first. So I'll probably build a monolith and launch it first. That's my plan. But there are stuff in there which is all coded to an interface, and I have already identified the things which are going to break out as the first gRPC services to be launched. And I guess that by the end of the year, we'll basically have all the gRPC services, and by the beginning of next year, we'll move to the new architecture using MLB. So why am I telling you my plan? Why do you care? It is because in order for you to overcome your FOMO, you need to have a plan. So you need to be able to say, if I choose this technology, I get all these benefits, but I also have these baggages. This is how I'm going to deal with them, which is what I have tried to do here. So thank you for bearing with me all along. That's the end of my talk. Thank you.
Thank you, Sathya, for the nice presentation. If you are watching this from YouTube, please leave a comment. So remember to subscribe to the channel. And if you want to speak at the London Clojurians, I will leave the details about the Clojurians meetup in the description. Get in touch with me. I'll set up a talk for you. If you have a library or a topic that you want to share, please get in touch with me. I will make sure that we can get some space sometimes. Otherwise, have a good night to everybody, and thank you for joining.